is the April edition of the Node.js and Oracle Database Office Hours. Thanks for joining us. Safe harbor statement: don't make any purchasing decisions based on what we say here today, although we don't intend to show you anything new or that you can't already do as of today. So who are we? I'm Dan McGann. I'm a developer advocate at Oracle. I focus on the Node.js and Oracle Database community specifically. We have Anthony Tuninga here as well. Anthony is the developer working on a lot of the functionality that we get coming out of note-oracledb. Christopher Jones, unfortunately, is not able to join us today. I believe he's on vacation. Hopefully we'll see him again next month. And we also have Blaine Carter on the line. Blaine is a developer advocate on the same team as myself, and he focuses on the open source communities. Just a quick overview of Zoom. If you've not used it before for one of these office hour sessions, you're able to ask us questions via the chat feature, which you see here. So just click there and fire away questions if you have them. And I'll do a brief icebreaker today. If you have any questions, so just go ahead and feel free to put them in the queue and we'll get to them right after. So in the last office hours, if you were here, we were looking at doing file uploads, and I was explaining that I'm going to explore 3 different means of doing these file uploads. So the first was buffering in Node.js. The second is going to be what we'll look at today with AsyncIterators. And then the last is going to be via a transform stream. And in all 3 cases, we're going to have the same sort of separation of concerns. We're going to have inside of our Node.js logic, both controller logic and then database logic. And so the difference really is that the controller logic is going to be aware of the incoming HTTP request as well as the response object that's often seen in Node.js web servers. And the controller logic is not going to have any idea about note-oracledb, for example. It's not going to get that low level. And then you're going to have the database logic, and it, of course, is going to use note-oracledb. It's also going to expose some public APIs that the controller logic can access. But the database logic is not going to know anything about an HTTP request or response. So that's the basic separation of concern that I'm trying to achieve in all 3 implementations. And when we look at what we're doing with scenario 2 here, and I apologize, these slides are not yet as full as I'd like them to be, but I'll just kind of explain it as we go. In scenario 1, where we were buffering in Node.js, we had the web browser. So imagine there's a file they want to upload into the database, and let's say that file is 100 megabytes. Well, the request is sent into Node.js, and what I did is internally just buffered all that data in here, 100 megabytes. And once we had it all in its entirety, we then sent it over into the database as a big gulp. And so that was nice in terms of simplicity, but it's not going to scale very well. So if you have only 1 gigabyte of memory available to Node.js, then of course you could only have 10 users uploading files concurrently. Otherwise you'd crash your process. And of course, the server is going to be doing other things as well. So you wouldn't even want to hit that number. In scenario 2 here, we're moving to the first of 2 streaming options. And the advantage of the streaming options is that we don't have to take the files in big gulps. We can start sending them, stream them through the web server and over to the database in smaller pieces. So when we do this kind of logic, we start to look at business-wise, what's the max file size? And perhaps in this case, we're going to say 1 gig, which is fine. We're not going to buffer that all in the mid-tier. But we do have to have some buffer. And in fact, as we'll see in the code, there's technically 2 buffers involved, although one's hidden from us. We're going to have our own buffer where we're streaming data in from the web server. And then the database will be pulling basically from that buffer and moving things over. And they'll be writing and reading just as quickly as they can. So that's the basic idea here with scenario 2. And we're tying these separation of concerns, both the controller logic and the database logic together using, in this example, we're using AsyncIterators. So let's take a look at the code. Oh, and I should show you very quickly. If you're not familiar with async iteration, I think one of my favorite blog post on this topic is here. Duality is actually quite old at this point, written back in 2016 when this was still a proposal, but we now have support actually in Node 10, so we can go ahead and start taking advantage of this. But it talks about what async iteration is, sort of some of the earlier things that we saw with just iterators and generators before it gets into the async stuff, but really good reference if you want to learn more about that. So what I'm going to do is start up a web server. We're going to go over to localhost port 3000 where I have this little file upload demo, and we'll just clear out any files in the database. I can refresh that, show you we're clean, and then I'll pick a file. This is the Apex application files. I'm going to upload one of those. You'll see we get some streaming data going across. Eventually the file upload completes, and then we can see that reflected down below. So that's the basic application and what we're trying to do. So let's take a look at how that was implemented. So I'm just going to start with the controller logic. Open that up. And we're looking at the HTTP post. So this is what the client is doing, a standard post request. And we get access to that request. And of course, in Node, the request object is going to be an instance of a stream, which inherits from event emitter. So there's certain events that we can listen to. In this case, I'm concerned with the data event, which will give me a chunk, a raw piece of memory. And this is my internal queue, just a basic array. I'm calling it chunk queue. And when the data comes in, I can push into that array. And then I'm tracking two things here. The total bytes received, we're just counting the number of bytes sent in the chunk, and then the total bytes in the buffer, which is that internal buffer I mentioned before. So I've declared a couple variables up here. So one is the max file size. In this case, file size can be up to 100 megabytes. This comment is inaccurate. So that can be up to 100 megabytes, and then max bytes in buffer. In this case, that's going to be usually a smaller number. It could be 1 megabyte, 10 megabytes. Both my comments were off in this case, but that's fine. So I'm using these constants and then these variables to add some business logic, as you can see here. So if the total bytes received has exceeded our max file size, we really don't need to accept any more data. We can just go ahead and cut that off. So you see I'm telling the request to pause, which means stop sending data upstream. And then we're just erroring out here and sending a response, an error response back to the client. Otherwise, we can continue on. And now I'm checking the total number of bytes in the buffer. And if we exceed the number of bytes that I want to see, then we simply pause the request and tell it, hey, hold off on sending us more data until we resume the stream. Sorry, just checking the question queue. So that's really the main thing that I'm doing here. And if I come down a bit further, you'll see a function that I'm calling get chunk from queue. And the way this works, I'm actually going to skip that function for now. We're going to come back to it. You'll see down below, I'm declaring a function called content iterator. And this is starting to implement some of the APIs and interfaces that you would see described in that blog post I was pointing to before. So this is how we create an async iterator. So it needs to return an object. That object has to have a next method, and the next method has to return a promise. And this promise is, the implementation of the promise is pointing up to that function up above. So I just separated those out so you could kind of see this a bit more cleanly. And then we also have the content iterable here. And in terms of the database logic, so this is what I actually end up passing to the database. This is our separation of concern. So really just focusing on these two things here. I get my iterable, and then I'm passing my iterable over to the database. So if we open up the database logic, you can see our create method here, takes the file name, the content type, and that async iterable. And with the async iterable, all we really need to do is go into this for await of. So this is a new for loop. So await of knows how to work with an iterable, and we'll just get a chunk. And as we get a chunk, we're writing it to a lob. So the difference between buffering it completely in Node and what we're seeing here starts with this insert statement. So I'm inserting into the table that will contain the files, but I don't have any data yet. This is very early on. As soon as the create method is called, we get a connection, and then we execute this SQL here. And what we're doing is inserting an empty blob just so that we can get a handle. We're binding that back out so we can get something that we can write into. And once we have that reference, that's when I start to leverage the async iterable. I'm just looping over the content and writing to the lob the chunks that we get. Once we're done, we can call end to signal to the lob that we're finished writing to it. And once all the data has been transferred over to the database, then this event here will be emitted, the finish event. Once that's emitted, we can commit our transaction and then resolve this promise here back out to the controller logic, returning the ID of what was inserted. Of course, we'll handle any errors as well. Earlier, I mentioned that we have a scenario with two buffers, one's hidden. What I mean by that is right here, where lob has a write method and it's writing the chunks. Technically, this write is writing to an internal lob buffer, so we just need to be aware of that and account for that in our memory calculations, depending on the number of concurrent users and uploads that we have going on. So just something to watch out for. But this is really the bulk of it. The only thing that is a little maybe strange in this get chunk from queue is the fact that this part right here, so it's going to resolve or reject, right? So this is a promise-based logic. And what you see is I'm checking the queue length. If we have some data queued up, ready to go, then we can just come into this block here and return it out ultimately. But I did need to wrap this resolve inside of a set immediate. And that may not be really obvious as to why on the surface, but it just has to do with the fact that technically promises are synchronous by nature unless you're doing an async operation within. And if the data is already queued up and we say, hey, give me a chunk, well, that's synchronous. I'm grabbing it from memory. And so I could end up in this loop where essentially I'm trying to get data from the queue, but at the same time, I'm trying to write to that queue. And I don't want to block the writes coming in, but if I read it synchronously, chunk by chunk, I will in fact block those writes. So this was a way around that, just sort of wrapping that in a set immediate, so it will act asynchronously. If we look back at some of the comments or the log output here, you can see what happens. So we got this thought it was in a post request, but I'm only seeing gets here. That's interesting. At any rate, once the file transfer starts, we get our data event triggered, and you can see we're starting to push data into that queue. Asynchronously now, at the same time we're filling that queue, we get a connection to the database. You can see data is eventually just going to keep flowing into the queue. Now I've inserted the row into the database, bringing back that empty lob locator so I can start writing to that. And then you're starting to see now iterations of that iterable within the database logic. And so we're starting to both read and write from that queue at the same time, but you're seeing a lot more data events writing to the queue, increasing the queue length in the beginning. And what will eventually happen is we'll get to this part here. We've written enough data to where we've hit that limit of how much we want in our internal queue, the queue that we're controlling. And so once that happens, you'll see a lot of push and pull. 161 elements, 60, maybe that'll vary just a little bit. But ultimately, of course, on the other side, you're going to see the reverse, which is now we're going to see the queue length start to come down. So there'll be a a point here where all the chunks are queued. So the HTTP request will let us know when we've queued everything up via the finish event, I believe. And then we just, at that point, start to flow it all into the database until it finishes and we commit our transaction. Here's that post request I was looking for. I forgot it writes after the fact, but not before. So that's it in a nutshell. I hope that wasn't too detailed or too high level either for folks. I have not yet made this code available. I do intend to blog about this in a series, starting with the first implementation, buffering in Node, then doing this one with AsyncIterators, and then of course the next one with transform streams, and hope to do that in the coming weeks. So keep an eye out for that. But if you have questions on this or anything else related to note-oracledb, we'll go ahead and turn it over to you. And again, you can use the talk features if you want to just unmute yourself or enable your camera. You can also just use the chat feature. We'd love to hear from you, so feel free to ask any questions. All right. Well, I guess we'll go ahead and call it there then. I just want to say thanks for joining us today. If you're interested in some more resources on note-oracledb, we have a few here, including a couple blogs, as well as the documentation. We do have a Slack channel, which you may or may not be aware of. If you want to join, you'll need to get an invitation, and the means through which you can do that is available in our documentation. So just go to that documentation link, search for Slack there, and you'll find the two links that you need. One will be the invite, and the other is just the normal channel. There's also a Facebook group for note-oracledb, and then the last one here is just the office hours, which you probably already have or you wouldn't be here today. Thanks again, everybody. Hope to see you in about another month. Have a good one.